Hello, welcome. Let's try to solve another Leetcode problem. 1233, remove subfolders from the file system. I quite like this problem. Yeah, because not only because this problem, the description is really easy to understand, but this kind of topic, like the file system, is really important for us in our real project, in our real programming. Yeah, so normally this is the structure for a folder. So this is a folder and with the folder name, and we have a forward slash first, and then we're gonna have a folder name and another forward slash and another folder name. So this is gonna be the structure. So what are we gonna return? So we're gonna return the folders after removing all subfolders in those folders. Yeah, let's try to understand it. So for the first example, currently, so for example, we have a folder A. Now, from A, we're gonna have a folder B. So this B gonna be a subfolder. So we need to remove this B. Yeah. Now let's check another one. We have a C folder and with a subfolder D, and another one is CDE. So CDE is a subfolder, so we just need to remove CDE. And we have another folder, it's going to be from CF. Yeah. So if there's a subfolder of my current folder, I need to remove it. So this is the idea. So what left behind is just those three ones, A, CD, or CF. Yeah. I think most of us might think about the trie, to use the trie to solve the problem. Definitely we can use a trie to solve the problem, and I think the trie is the best method to solve such problem. But for the programming, while you are using trie, it's not easy to code. I mean, basically, it's not that so hard, but basically we need to be really familiar with how to implement the trie. But first method, I think we can use a stack with sorting. So if we sort the folders, so what's gonna happen? So let me make a drawing. So if we sort folders, we're gonna have a character A, forward slash with character A, and another forward slash with character. Yeah, let me make it better. Maybe the drawing is not so good. Yeah, so this is gonna be a forward slash. Yeah. So we have forward slash with A, forward slash with A and B. So this is just after sorting. We can sort the folders array. And we also have the CD, so this is going to be CD, and another one is the CDE. So we also have C, this is going to be D, and this is E. So this is the CD, and this is CDE, and the last one going to be CF. Yeah, so this is just after the sorting. So what we can do after the sorting of the folder array, so after sorting, we can see that for the first word, it is a slash forward slash with A, and for the second one, if it is a subfolder, it always followed the first folder. So for example, this is forward slash A. So another one, if it is a subfolder, it always follow the previous one. So for example, if this is a forward slash with A and forward slash with A and forward slash with B, so this means this is just a subfolder. So we will ignore that, and we're gonna put the forward slash A inside of the stack. Yeah, and now we're gonna check the next. So next the CD. CD is not subfolder, and how can we check that is a subfolder? We can use in Python. We can use the start with. If start with. So for example, if this word starts with the previous word, it means this is a subfolder, and we just need to remove it. And if it is not, we're gonna put it inside of the stack. And for this one, this is a subfolder. We just remove it, and this one we remove it. And what about this one? This one is not a subfolder, so we just put it inside the stack. So as you can see, the stack idea is really easy to code. And now let's just check the stack idea to solve the problem. Yeah. So first of all, I'm gonna sort the folder. After that, I'm gonna take the first. I'm gonna take the first folder inside the folder array. After sorting, I'm gonna take the first folder inside my stack, and then I'm gonna check from the second. Yeah, I'm gonna check from the second folder. So if the second folder not starts with stack minus 1 on top of stack. If this AB not starts with A, so what is going to happen? We just need to put it inside the stack. Yeah, we just need to put it inside the stack. But this is a start with, so we cannot do that. But for CD, we can put it inside the stack, and for CF, we can put it inside the stack. And there's another case. We have to be careful, otherwise definitely we're gonna make mistakes. Yeah, because some of the folder structures, it is not just a character. It can be 2 characters. It can be a word. For example, this is a CA. Yeah, so this means we have to have another tag. So another tag is the length of the stack minus 1. So for example, this is the stack minus 1. So the length of the stack minus 1 for this example is going to be 6. I think it is 6. Yeah. So for this one, if my folder with the length 6, so it's going to be this character C. So if it is not equal to a forward slash, basically this means it is not a subfolder. This is another case. We have to check that. Yeah, so if not equals to forward slash, so we're going to put it inside the stack. It means this F folder is not a subfolder of my previous folder on top of the stack. Yeah, so finally I just need to return the stack. As you can see, the stack idea is really easy to implement, and the only difficult part may be this one. Maybe you're gonna submit it and make a mistake. Then you're gonna think about we have to have another check. We have to check, yeah, this length of the stack minus 1 should not equal to forward slash. Yeah, because only in this way it means it is not a subfolder. If it is equal to forward slash, basically it means it is a subfolder. So we have to check this condition. Now let me just run it to check. As you can see, it works, and let me submit it. Yeah, as you can see, it works and it's pretty fast. Because the time complexity, as you can see, first of all, we're gonna have a sorting. So for the sorting, it is n log n time, and the length of folder is 10 to the power of 4, so it is okay. So n log n, and with the length of the folder, so it is 100. So basically, it means it is 100 times 4 times yeah, it is 100 times 4 times 10 to the power of 4, and times a log, and the log of this number maybe it is just 12 or 10. It should be okay. So the final result gonna be yeah. So the final result gonna be 48 times 10 to the power of 6. So it's gonna be like 5 times 10 to the power of 7. Yeah, so this is why we can pass for Leetcode. Yeah, so this is just a calculation for the total time complexity. It's gonna be n log n times the length of the folder. Yeah. Now let's go to the better idea. So the better idea is that we can use a trie. Definitely, the trie is the best way to solve such problem. Yeah. So let me first explain why we can use a trie. So we have this kind of structure. So we can put the forward slash with A inside the trie. So we put a forward slash with A, and another one we're gonna put a forward slash with B, and for the next one we have forward slash C, and we have forward slash B, and for the next one we have forward slash with E. Yeah, as you can see, the trie structure is really good to solve such kind of problem, because definitely we can represent it. And for another, say we have a F, so forward slash with F. Yeah, and from here that's going to be the root node. So this is just the trie structure. So after building the trie, the next step is that we're going to starting from the root node, and we can use a DFS. We can use a recursive function DFS to find all the to find all the folder that meet the condition. Yeah, but we just need to remove the subfolder. But how can we remove the subfolder? So for example, this is A. From here, we can prepare the end of the word. It means it ends from here. So we can set an end of word to be true, and for this AB we can set the end of word to be true. Yeah, And also for this cd, we can set the add of word to be true, and from this cde we can set the add of word to be true, and cf we can set the add of word to be true. So while we are using the recursive function, once we find that is the add of word, we're gonna stop it immediately so we can get the folder with / with a. And for here, this pass, while we find a true, so this is a true, so we just need to return the structure C and D. And for here, if this is a true, we just need to return the structure of C and F. But we need to ignore these areas with / e, and we can, yeah, we just need to ignore these areas. So I think everything should be okay for the problem. Yeah. Now let's just go to the coding of trie. Yeah, I did this before, so I don't want to waste so much time to rewrite the code again. So for the trie, we just need to prepare the basic structure. We're going to prepare the self.children and the add of the word. And for the trie, we're going to initiate. So this is the node, and we're going to initiate the root node. Yeah. So the only difference is that for the insert function, we're going to split the word. We're going to split the word with a /. Yeah, I'm sorry. So in my explanation, I ended with /. Actually, we don't need it. So this is A, and this is B, and this is just C, and this is D, and this is E, and this is CF. Yeah, basically we don't need to use the /. That should be okay. Yeah, but for us, we just need to split it because it can be a character of it can be 2 characters CA. Yeah, the folder name can be CA. It's gonna be 2 characters. Yeah, so first of all, we're gonna split it. Then we're gonna use the basic structure, basic template of insert a word inside the trie. Yeah, so after insert it, at the end we're gonna set the add of a word to be true for each of the word. Yeah. So here is the only difference. Yeah, because sometimes it's gonna be CA, so we need to split it from here, from the insert method. Now, let me just comment these areas and uncomment the trie. Yeah, so from here, we just need to initiate the trie to be T, and for T inside the folder, we just insert it. So we're going to insert all the folders inside the trie. Yeah, so for each of the folders, we're going to insert it inside the trie. Now, we just prepare the root node. So the current going to equal to the root node, and the result going to be my final result. And we just need to use a DFS. Yeah, so for this DFS, basically it is a backtrack function. So for the backtrack function, I'm going to prepare a current. This current is my root node. As you can see, this is a t.root. And the answer is going to be an empty string. So I want to check if it is the end of the word. If for this root node, if it is the end of the word, I just need to put the answer inside my result. And I'm going to give a return to let it stop immediately for the backtracking. And then I'm going to check all the children inside my current.children, because current.children is just a dictionary. I just need to check all the letters. Maybe from the beginning, the letters is just a C. So I want to check this A and this is C, and this is A and this C. Yeah, and now I still need to use the DFS. So for the DFS, currently it's going to be the current.children with this child. So this means it's going to be current children with this A, or current children with this C for the recursive function. And I need to use the empty string answer. It's going to be empty string. So plus the child plus this character A. So for this one, it is a character A. I'm gonna plus this character A plus a forward /. Yeah. But after that, so what I can return, let's check what is the result. So this means at the end of the word, I always have a yeah, let me just check the result. Yeah, let me use the first example maybe. Yeah. So my result gonna be here after the DFS. Yeah, so this is going to be my result. Actually, as you can see, there's another forward slash at the end of the word. That means finally I just needed to remove that. So that is why I use the s with the slice -1. So for s inside of the result. Yeah, but before it, let me just print it from here. Yeah, but before it seems everything should be okay. I'm not sure. The second, the third example, it seems everything's okay. I don't need to do that. Let me just check. Yeah, so let me just check. Do I need to use this s with the slice -1? Yeah, so this is my insertion, and so this is my result, and this is my result. Yeah, I think I need to, yeah, definitely I need to use it. So after DFS, let's check what is the result. Yeah, before the result is empty, so after the DFS, so the result would be like this. And then I just need to remove the last character, which is the forward slash. So I just remove the forward character and return the final result. Yeah. I think the only difficult part may be here. We need to check, we need to split it with a forward slash, and also here for this backtrack function. So for the DFS, we need to check if it is the end of the word, we need to put the answers inside of the result array. And also for here, for the DFS, we need to prepare everything. From here, it is empty array and plus a character, maybe A or maybe C, and plus the forward slash. Because at the end of the folder, there's a forward slash, we just need to remove it. Yeah. Now let me just submit it to check if it works. As you can see, it works. Although the speed is slower, but it doesn't matter. Let's analyze the time complexity. Because while we are using trie, definitely we use the class, we use the hash table, it consumes the time. It doesn't mean for calculating the time complexity, it's going to be slower. It's just because the physical properties of the computing time, it is slower. Yeah. Yeah. Now let's just analyze the time complexity. So for each of the folder, we want to put it inside. Yeah. So we're going to check the length of the folder and how many folders. So it is 4 times 10 to the power of 4 times 100. Yeah, so this is for insertion. So while we insert the folders inside our trie. Yeah. Now from here, it is just a recursive function. So this recursive function actually, it is dependent on this. This recursive function, or this like a backtracking function. It is dependent on the how many nodes do we have. Yeah. So, but it can stop earlier because while we find the end of the word, it's gonna basically stop earlier. But if it is not, it will always depend on how many nodes do we have. So the total number of the nodes is gonna also be 4 times 10 to the power 4 times 100. Yeah. So by calculating the time complexity, actually the trie is better, because for the trie, the time complexity is this 4 times 10 to the power of 4 times 100. Basically, it is 4 times 10 to the power of 6. Yeah. So while we are using the stack with sorting, the time complexity, if I remembered right, it's going to be 5 times 10 to the power of 7. So this is why we prefer to use a trie, although the running time is slower, but actually the trie is a better method. I think that's all for today. Thank you for watching. See you next time.